Okay, for tonight's homework video, I'm just going to have you again copy these 7 problems that we did today in class just for review to make sure you're really caught up with what we're doing, and make sure you're writing down the secret 5-word message to prove to me that you also listened to this. So again, make sure you write all of this work and listen for the 5-word secret message. Alright, first problem is solving by substitution. This first problem has y by itself, so you can see they took this chunk right here and plugged it into the other equation's y. So where that y used to be, they put 2x plus 3. The first word is black. So when they did this problem, the 4x is still there, but where that y used to be, I have 2x plus 3 right there. And then they combine like terms to get that 4x and 2x to get 6x, brought down to 3. First step right there, take away 3 on both sides, gives you 6x equals negative 12. Divide 6 on both sides, and that gives you x equals negative 2. Don't stop there. That's only half of the answer. Go back to the easy one, solve for y, and where there's an x, plug in that negative 2. So I have y equals 2. And where that x used to be, I plug in negative 2 in there, and I get negative 4 plus 3. So y equals negative 1, written as a coordinate, is negative 2, negative 1. So let's get this as a slideshow so we could see it a little bit better. And to start my slideshow. Alright, here it is, a little bit better. Sorry about that. So again, this one is negative 2, negative 1. If you plugged in negative 2 for x and negative 1 for y, they would make both equations work. Alright, number 2. For this one, a little bit harder. This one, you had to solve this bottom one for y by taking away 5x on both sides. So minus 5x. Right here you can see minus 5x, those go away, and you get y equals negative 5x plus 8. This is being substituted right into the other equation's y, where that y used to be. I'm going to put that whole chunk, negative 5x plus 8. So you can see I still have 3x, and I still have that 4, but where that y used to be, I substitute negative 5x plus 8 equal to negative 2. I have to distribute. 4 times negative 5 is negative 20x. 4 times 8 is 32. Combine your like terms. 3x minus 20x gives me negative 17x. Bring down the plus 32. Bring on the negative 2. Opposite of adding 32, subtracting 32 on both sides gives me negative 17x equals negative 34. Opposite of timesing is dividing by negative 17, which gives me x equals 2. Take that answer, plug it back in. So if I go back to this original y equals negative 5x plus 8, and where that x is, plug in a 2, I get negative 5 times 2, negative 10 plus 8 is negative 2. So putting those answers in the right place, x is 2, y is negative 2. If you were to check it, 3 times 2 is 6, 4 times negative 2 is negative 8, 6 minus 8 is negative 2. Plug in 2 right here, 10. Negative 2 right here. 10 minus 2 does give you 8. So that check does work. Next problem. For this one, you had to solve this inequality, solve both these for y, and then graph them. So that first inequality, and the second word is flash. So for this first inequality here, I had to take away 2x on both sides. Those go away. Make sure you bring down the negative with the y, greater than negative 2x plus 1. But this step right here, because I want y by itself, I do the opposite of timesing by negative 1, which is dividing by negative 1. Divide that all the way through each term. That makes my inequality switch from more than to less than. This gives me positive 2x. This gives me negative 1. The second equation, to solve that for y a little bit easier, all I had to do was subtract x on both sides, and that gives me y greater than negative x plus 2. When I graph it, this one has a y-intercept of negative 1. It's got a rise of 2 over 1, 2 over 1 is my slope. So up 2 over 1, up 2 over 1. That's going to be a dotted line because it's just a plain inequality without the equal line under it. That is less than. So for that dotted line, I shade below, below, below. The next equation, positive 2 for my y-intercept, but this has a slope of negative 1 over 1, negative 1 over 1 in front of x, which means from here I go down 1 over 1, down 1 over 1. Solid line because of that inequality, and that is more than. So I shade above, and you can see of these 4 quadrants, this quadrant is the one they overlap, so they show me overlapping lines there best they could. Even picked a point in the section 3, 2 that you could check if you wanted to. So 6, 3 times 2 is 6. 6 minus 2, 4, bigger than 1, yes. 3 plus 2, 5, bigger than negative 2, yes. So both those numbers would work in the check. All right, next problem. For this one, they ask, which line is parallel? This line has a slope of down 1 over 2. That's a slope of negative 1/2. Down 1 over 2. Negative 1 for my rise, 2 for my run. I need to find the equation down there that has that same negative half in front of x, but also a different y-intercept. This would be the same exact line. Don't want to pick that. That's not the definition of parallel. Parallel is same slope, different y-intercepts. So this parallel line would really start here at 3, go down 1 over 2, down 1 over 2. So it would be a parallel, never touching, never intersecting line through a different y-intercept. The next word is puppy, puppy. So for this one, the equation is y equals negative 1/2 x plus 3. That is the parallel line to this red line. Next slide. This one asks, which is perpendicular? So if I go down 1 over 3, that's a slope of negative 1/3. I don't want to pick equal to that because that's not the definition of perpendicular. I don't want to pick the opposite of that. That's still not perpendicular. Perpendicular is the negative reciprocal. So not only am I flip-flopping this, I'm doing the opposite. So if I take that negative 1 over 3 slope and flip it and then do the opposite, it's going to be positive, and it's going to be positive 3 on top, 1 on the bottom. The only one that has positive 3 is this choice right here, 3x plus 1. That 3 over 1 is the opposite reciprocal of that one right there, which is the slope of this line. But don't pick that because that's the same slope. Don't pick that because that's the same reciprocal, just flipping this, not doing the opposite. And then don't pick this because it's not the opposite of the slope. Be careful for that. It is negative reciprocal. All right, sixth problem, a little bit harder. This one is asked if it's perpendicular or parallel, but you can't tell by looking at it. You have to solve this for y first. So you can see their work. Minus 2x minus 2x. Good job, math students. Those go away. Bring down the 6y. Negative 2x minus 36. Divide everything by 6. That gives me y equals negative 1/3 x minus 6. You can see this has the same slope. This is down 1 over 3. Negative 1/3. Same slope, different y-intercept. So this one would be down here at negative 6 over 3 down 1. So a parallel line with that same slope. Yes, that is parallel. Next slide. The next word is down, down. All right, this asks perpendicular or parallel. So for this one, I do 4x minus y. I solve that for y. You can't tell until you solve for y. Minus 4x on both sides. Bring down the negative y. Bring down your equal. Don't combine those. Negative 4x plus 2. Divide everything by negative 1, which makes that positive 4x, negative 2. And you could see this line has a slope of negative 1/4, down 1 over 4. If you take negative 1/4 and flip it and do the opposite, it becomes 4 over 1, which is, yes, indeed, this line right here. So, yes, that is perpendicular, where the one before it was parallel. So this line in this equation, these are perpendicular. All right. So again, write down that message and good luck.